Find the equations of the tangent and the normal to the function f of x is equal to x squared minus 3 at the point p to 1. Before we actually go ahead to do this algebraically, let's just have a look at this geometrically. So here we have the curve f of x is equal to x squared minus 3. If I click here, we now have a point P. This is at the point at the moment 2, 1. And if I click this one here, this red line here is the tangent drawn at P. And then if I click this one here, we get a line perpendicular to the tangent at P, and this line is called the normal. It is possible to find the equation of the tangent and the equation of the normal, and this is what we're being asked to do. If I just move the slider around, you can see at any point we have a tangent, but the normal is always perpendicular to it. Okay, so just move it back to the point where we're being asked to find it. So we're actually being asked to find it at this particular point here, to 1. So we're now going to look at the steps needed in order to do that. Right, so f of x is equal to x squared minus 3. The first step is that you need to differentiate the function. So differentiating the function, the rule is if f of x is ax to the n, then f dashed of x is an x to the n minus 1. So all we need to do is bring that 2 down in front, produce the power, so we're going to get 2x, and if we differentiate a constant, we get 0. So we write down f dashed of x for gradient function is equal to 2 times x. Step number 2 is we find the gradient at the point P. The point P has coordinates 2, 1. So at P, x is equal to 2. We now substitute 2 into that, so we get that f dashed of 2 is equal to 2 times 2, which is equal to 4. This now is actually the gradient of the tangent at P. This is the value of the gradient. We like to use the letter m for gradient, and because it's the gradient of the tangent, I'm going to use m with a little t. Step 3 is now we can find the equation of the tangent. So we know that mt is equal to 4, and we know the point P is 2, 1. Now there's a formula for finding a line where you know its gradient and one point on the line, and this is this formula here, y minus y1 is equal to mt x minus x1. So we need to substitute these numbers in here at the right place. So this is mt, this is all a good idea to write underneath each one what they are. This is x1, this is y1. So we're going to have y minus 1 is equal to mt, which is 4, brackets x minus 2. Now we're going to use our algebra. So first of all we will expand the bracket. So expand the bracket, we're going to have y minus 1 is equal to 4x, 4 times minus 2, which is minus 8. Then all we're going to do is move this one over here. We're going to add 1. And then if we do that, we're going to have that y will be equal to 4x minus 7. Now if we write it this way, this is the form of a straight line, which is y is equal to mx plus c. Point number 4 is we have to find the gradient of the normal nm. Now before that, if we have a tangent, then we know the normal is going to be perpendicular, so that both of these are drawn at P. So therefore this angle here is 90 degrees. So what is the condition for gradients? So the tangent and the normal are perpendicular, i.e. at right angles to each other. And if we call this one mt, and we call the normal, the gradient of the normal mn, so these stand for the gradients of these lines. The condition for lines to be perpendicular, if you multiply mt times mn, you're going to get minus 1. So hence, if I want to find mn, it's going to be minus 1 over mt. And this is worth remembering this one here. So the gradient of the tangent is 4, but therefore the gradient of the normal is going to be minus 1 over mt. So that's going to be minus 1 over 4. Step number 5 is that we can now find the equation of the normal. We use a similar formula. So writing down mn is minus 1 over 4, and that point P is 2, 1. We now use y minus y1 is equal to mn. This is the only difference of x minus x1. So y minus y1 will be y minus 1. Sorry, write down mn underneath x1 and xy1. That helps you substitute things in the right place. So we're going to have y minus 1 is equal to mn. So it's going to be minus 1/4 brackets x minus 2. Now if you multiply this bracket in here, we're going to end up with fractions, so it's not going to be very nice. So it's better to multiply both sides by 4. So we're going to get 4 brackets at y minus 1 is equal to minus, because we've still got minus sign here, of x minus 2. Expanding the brackets, we're going to get 4y minus 4 is equal to minus x plus 2. And now what we're going to do is we're going to add x and take 2. So we're going to take the x over here and take away 2, and we end up with x plus 4y minus 6 is equal to 0. Now equations written in this form are considered to be ax plus by plus c is equal to 0. So what we've done here is we found the equation of the tangent and the normal of a curve at a particular point. So we just go back to our drawing. So we've got the equation of this line, and we've worked out the equation of this line. So we've got 4y is equal to 4x minus 7, and this has given me minus x minus 4y is equal to minus 6, which is what I've got is x plus 4y minus 6 is equal to 0. It's the same thing.